know the known scientist in this. I know the famous scientists right now, on the talk show. They understand this one to my satisfaction either. So don't worry about that one. So now back to the density about it. Did you see the laser lights? You can see the laser lights. See every particle. You see all the passes light up based on called the diffraction law of diffraction. Each point, this is a classic definition of the law, classic law. Each point is a second light source, secondary light source, generate light, right? So we know every single point is a source. What that means, every single point has this magnetic fluids, magnetic particle. They are excited, they are starting motion. When magnetic particles start motion, all surroundings will have a ripple effect, create lights. Just give you a sense of how dense this material is. Another example is also based on the modern physics study measurement. We know the sun has a explosion and also emitted this called the neutrinos. The neutrinos, how dense the neutrino is. The neutrinos are passing every square centimeters, basically just a fingernail size, 65 billion particles per second without a detect. So you know how dense, how small this particle. So that's why we can see every single particles can become a second source of light. So basically it's a very dense. Okay, the rest of them should be relatively easy. So now let me just talk about the vacuum. So why they said, why physicists said we measured, we know this space empty because we could not measure pressure. How they measure pressure? They all measure pressure based on relatively pressure difference. So now we know neutrino can travel at the speed of light, passing the entire Earth without resistance. So what happens with your measurement equipment? If you look at the container, so to neutrino, this container is non-exist. They are so small, they will be equalize the pressure everywhere in the universe. So traditional measurement will not work unless you have a new measure. So we are not missing, we are not proving there is no light transmission medium there. Actually, we prove they are there. We know neutrino. Neutrino is no barrier in the universe right now. They can pass the sun, something. Okay. What does that help me? Explain. This is the one thing about it. If I know everybody, I talked to also knew Albert Einstein. The only Nobel Prize he won is this called the photoelectric effect. Remember, he developed a theory, special theory relativity, and the general theory relativity was never being awarded because it never been understood. However, this test is the only one on the paper he won in 1921, Nobel Prize. For what reason? Einstein successfully argued. This is the test. When lights come into this special positron, this material, we can detect that there's electrons that goes out. So he said that this demonstrated this is light is a particle effect. That's what he won. So now, with the new understanding we have here, I try to tell you this is 100% wave effect. Have nothing to do with the particle. Let me tell you, the first thing I see this one. Did you see the light particle coming into different color? What the color means? Color means a different frequency. What frequency means? Frequency means particle vibrating in an elastic medium. That's not coming from light. That's the medium. So when we see lights, every particle already saturated next to our eye is vibrating. There is no transmitting particle from a light source transmitted to my line. There isn't anything. Electrons does not travel through glasses. So only thing is a vibrating magnetic medium. So what we see light is medium light. So when I see, wow, how can you say light is a particle when, and you see even light has a frequencies, right? Different colors. Itself means, oh, okay, this is a medium vibration frequency. You got it? I hope, Ocon, he's the expert, on vibration. If he got it, everybody will be even more expert. Okay. So how the electron came out? I just want to explain why the electron come out. We know the size of the neutrino. Neutrino is a million to 10 millions, as a millions size less than electrons. Basically, entire mass, entire atoms, entire electrons, all soaked in this oceans of this magnetic field. And when your frequency vibrating, and when you reach to the natural frequency, what happens? The vibrating triple, double, triple, and right until shake everything up. So it basically is a shake the vibration environment, the medium, the ocean, shake this particle loose. I hope you got it. The reason I mentioned here is my ex-boss. He got a PhD in quantum mechanics. Okay, he told me. I asked him, so is light a wave or particle? He said, oh, wave. But he said only one thing. Okay, is a particle. Talking about this photoelectric test effect. So then I just say, okay, photoelectric effect is 100% a wave effect. Okay, thank you. Okay, another thing, I try to extend this understanding. Say, well, we receive signals. You use cell phone, receive signals from vibrating this kind of magnetic particles, right, in the wave. So what happens to electricity? So I wanted to share what is electricity. We always been led to believe electricity is electrons travel at the speed of light inside our cables, connectors. My discovery is not, it does not say they cannot, but that's not what I believe what really happening. What is really happening? We don't need, I do not believe electrons travel at the speed of light in the cable, just oscillating. Just oscillating. If one, we know all the atoms. We're talking electrons. What I told you, electrons is nothing more just a little magnet. So all other atoms actually is a magnetic field, magnetic field. If you change one, what happens? Chain reaction. I got another confirmation from my friends. Okay, chain reaction. This chain reaction actually is a wave propagation. So no particle moving from position A to position B. However, when rotating, ripple effect traveling. So that's why we always know electricity travel at the speed of light. That's a wave always travel at the speed of light, travel at a constant speed. If particles, if bumping something back, it will travel negatively. You will not see the positive speed. That means particle can change path, can bounce back, will never travel at a constant speed. So whenever you know constant speed of anything, there's a wave effect. So I just basically say, what is electricity? Really, it's just magnetic particle oscillating and chain reaction. As one example, I'm talking about the microwave. Why microwave can warm? Not just you do not want to put any metals in there. Put metal in, you will suddenly create electricity. We're burn out. That's hazard. Okay, don't try that one. But when you put food, all the food you put it, they warm everything you put it in there. Why? All the stuff have magnetic pole in there. Basically, it's oscillating. And another example, a famous experiment that they put a light bulb in the microwave. What is the drive force in the microwave? Microwave only is alternating magnetic field. That's all they do. Alternating magnetic field. When you alternating magnetic field, you see He's finding the light bulb lit up, create electricity, right? Basically, I'm just telling you, so the electricity is nothing more just oscillating magnetic particles. Another example is a charger. We charger, we have a charger station with a cell phone on top. What the charging station do? Just oscillating magnetic field, and then your battery gets charged. With that, I'm trying to unify or try to explain Maxwell equation. Maxwell is the greatest scientist, the most successful, most fruitful scientist since Newton, the greatest scientist based on the Einstein's account. What he did is he unified electric field and magnetic field and the light, right? He unified based on mathematical equation. If you look at the both sides equation, so in the middle, if you underline, in the middle say Maxwell equation. The left side and the right side. One is a magnetic field, one's an electric field. You look at the equation, identical, right? That's how he successfully unified. What is a fundamental cause? See, electric generator is nothing more just a piece of a wire rotating in magnetic field. What happens when you have a wire rotating in magnetic field? All the particles in the wire which also have a magnetic poles, so will be oscillating. So that's how create the electricity. And then you look at the lower right corner. So that's electric motor. Motor driven by what? By alternating magnetic field. So basically, I'm trying to say, electricity, we can wipe out the electricity out, or electrical out. It's just oscillating magnets, right? So unified one. Now, what time? Okay. So I may have to pick up the pace faster. Now let's look at what happens to I want to introduce the modern physics. Okay, let's watch this video first.
Mechanics. Quantum mechanics comes out of the struggle to understand the structure of atoms. What physicists in the early 20th century learn is that in the world of the very small, the seemingly impossible is commonplace. Things don't exist until someone looks at them. We're unable to say exactly what path something takes to get from point A to point B. Uncertainty and chance are woven into the very fabric of existence. There are some physicists who refuse to accept that quantum mechanics represents the full story of the subatomic world. The most famous is Albert Einstein.
Quantum mechanics is very worthy of regard, but an inner voice tells me that this is not the true Jacob. The theory yields a lot, but it hardly brings us any closer to the secret of the old one. In any case, I am convinced that he doesn't throw dice.
The world's greatest physicists gather in Brussels in 1927. Einstein challenges Bohr and the idea that uncertainty rules the world. Werner Heisenberg writes in his diary,
"We all stayed at the same hotel. The discussion usually started at breakfast, with Einstein serving us up an imaginary experiment by which he thought he had definitely refuted the uncertainty principle. In the course of the day, we would have discussions on the matter, and as a rule, by supper time, we would have reached the point where Niels Bohr could prove to Einstein that even his latest experiment failed to shake the uncertainty principle. Einstein would look a bit worried, but by next morning he was ready with a new imaginary experiment more complicated than the last.
One of Einstein's challenges is so clever, it has Bohr deeply concerned for the future of quantum mechanics. Physicist Leon Rosenfeld writes,
Bohr did not see the solution. I shall never forget the sight of the two antagonists leaving the hall. Einstein, a tall, majestic figure, walking quietly, with a somewhat ironic smile, and Bohr trotting near him, very excited. During the whole evening, Bohr was extremely unhappy, going from one scientist to another, trying to persuade them that it couldn't be true, that it would be the end of physics if Einstein were right.
Bohr spends a sleepless night in his hotel room before he discovers a flaw in Einstein's argument. Ironically, it involves a subtle application of Einstein's own theory of relativity. God does not throw dice was Einstein's unshakable principle, one that he would not allow anybody to challenge. To which Bohr could only counter, nor is it our business to prescribe to God how he should run the world.
Okay, the reason I show this video is, if you listen closely, they both, the giants, the founder of their individual, they are the founder of modern physics, the two pillars. One the founder of relativity, one is the founder of quantum mechanics. They are fighting for their lives. Why? You see, each one of them believe the other one is completely wrong. You see, Einstein said that, God does not throw dice because of quantum mechanics. Remember, quantum mechanics, electrons circle around, jumping back and forth, and nobody knows the locations. Only location determined by what is called probability wave functions. Remember, Einstein's fundamental thing that this is a something fundamental wrong. He was correct. And why Niels Bohr fighting so hard said, if your Einstein's correct, physics is dead. Remember, he said that one. Why? Quantum mechanics said every single fiber, every single atom has an electron traveling at the speed of light. What Einstein said, nothing in the world can, no particle in the world can travel at the speed of light. What happens if you do travel at the speed of light? In Einstein's equation, one electron travel at the speed of light, you will have a mass, infinite mass. One mass will be bigger than the entire universe. So you know why they're fighting so hard. They're fighting for their lives. Got it? And so now, let me tell you why these two theories cannot be reconciled. Brad wrote a wonderful piece, you know how to reconcile Einstein's theory with quantum field theory, right? He knows exactly what I'm going to say, so he alluded to that one. Relativity founded on what principle? Constant speed of light. Universally constant, only one thing is constant, the speed of light. Everything is relative. Universe, the size, dimension, time, mass, everything relative. Quantum mechanics founded on everything is absolute. Basically the classical mechanics. Their foundation are totally different. If anybody can reconcile this one, I know it. There's several people win Nobel Prize by proposed reconciliation of them. They all win Nobel Prize. Okay, that was completely wrong. Okay, so mutual exclusion. Okay, so now I'm talking about that was two giants fighting each other, right? So now we're talking about does anybody theory can really explain the whole world, right? If one of them correct, the other one is out, that's okay, no problem. Let's see what's the problem with both.
Einstein's equations of general relativity simply say the following. The Ricci curvature tensor minus 1/2 the metric tensor times the contracted curvature tensor is proportional to the stress energy tensor. All this says that if I start with a star, a black hole, or even a universe that determines the curvature that surrounds that concentration of matter and energy. But inside these equations, there's a monster.
In the extreme gravity at the core of a black hole, Einstein's equations spiral wildly out of control.
After a very long, tedious calculation, I mostly get zeros, but the non-zero term is given as follows. M is the mass of the black hole. R describes the distance from the black hole. Here is the problem, right there. When R is equal to 0, the point at which physics itself breaks down. So 1 over R equals 1 over 0 equals infinity. To a mathematician, infinity is simply a number without limit. To a physicist, it's a monstrosity. It means that, first of all, gravity is infinite at the center of a black hole, that time stops, and what does that mean? Space makes no sense. It means the collapse of everything we know about the physical universe. In the real world, there's no such thing as infinity. Therefore, there is a fundamental flaw in the formulation of Einstein's theory.
The search for a theory of quantum gravity had fallen apart, because quantum mechanics and general relativity proved to be totally incompatible.
I think the most embarrassing problem we have in theoretical physics is that we have these two different theories which won't talk to each other.
The failure of these two great theories to understand black holes means they are, at best, an approximation to the laws governing the universe.
The equations no longer make any sense. And nobody knows exactly what we're supposed to do about that.
Well, it's awful. It means that physics is having a nervous breakdown. It means the collapse of physics as we know it. You know, something is fundamentally wrong. Nature is smarter than we are.
If we want to understand the universe, we must understand how quantum mechanics and gravity can live together. And so that's our challenge.
So it's quite a big question.
It's a huge question. There aren't questions much bigger than this. We don't understand.
For nearly 100 years, physics has been able to explain the universe around us. General relativity perfectly describes the motions of stars and galaxies. And the world of atoms is beautifully explained by quantum mechanics. Yet the discovery of black holes means we don't fully understand anything.
Okay, this is just demonstrate the two theories, cannot be reconciled, has been tried by almost 100 years, right? Because they are fundamentally different. Okay, for the benefit of most people who initially, for my other presentation talking about the Einstein quantum mechanics, so I feel like I still have an obligation to at least introduce what is theory of relativity. So give just a little bit of understanding to it. When we're talking about the special relativity, it's basically Einstein's version of the equation of motion. Say if anybody, any particle in motion, what kind of relationship between, in this case, between the energy and the velocity of particles. Yeah, that's the equation of motion. And so which is equivalent to Newton's law of motion. And for the general relativity, Einstein's general relativity is basically Einstein's law of gravitation. So gravity, talking about gravity. and for equivalent to Newton's law of universal gravitation law. So that's just simple say. So one picture I found it very funny when I first look at modern physics is in modern, they call it modern physics. They said why there's no Newtonian? Why they even have like a modern physics versus a classical physics? I said that's funny. Why they have them? In modern physics they think about Newtonian classical law of motion does not work in this called high energy, high velocity type of physics. I struggled. I said this is very odd. In Newton's mind, he developed this law, universal law. Why it does not work in that area? I can feel. Newton is furious up there. He sold everything he could at us. He said, you misunderstood me. I can feel them. And so, but why? Why modern physics think about Newton is out, is obsolete, is approximation, is no longer accurate. It's all based on, if you look at the yellow box, talking about, this is a test measurement, is empirical relationship. This is established with measuring electron mass, the mass of electrons. If you look at the equation has an inverse term, so square root of 1 minus velocity, that's particle velocity square divided by speed of light. It has this term. If you look at this term, what happens if the velocity of the particle reaches the speed of light? The mass equivalent to infinity. So this term talking about the mass can change. That's from empirical relationship. So now let's look at it. So in Newton's equation, mass is conserved. Mass does not change with your how fast or how slow you move, right? Mass cannot be created, cannot be destroyed. It only can transformed. You can divide the particles, so less mass or something. You cannot create it from nothing. In this modern physics, the mass created by higher velocity. Velocity change, mass increase. Sounds very funny, right? I know, sounds funny to everybody. However, this is a test data. Now you look at the entire theory relativity. If you look at all the relationship in the theory relativity, the very bottom number 4, the light, the time, the distance, the length, distance, and the mass, it's all based on the same inverse relationship to the square root, right? So it's a carbon copy over here, right? So it's everything derived based on that experimental relationship. So whenever you test Einstein's theory, you basically test this experimental relationship, which was correct, has been tested thousands of times, right? So so that's experimental. So now we think about it. Why we say light is the universal speed limit? In order to use this relationship, we know if any particle's velocity reaches to speed of light, then mass become infinite, right? We cannot pass that. So that's the reason. That's the fundamental drive. Why the theory isn't very difficult to understand, but you don't need to understand, because end up always will end up with this relationship. So this relationship shows, if you measure electrons and subatomic particles, you will end up with this relationship. I will tell you why this relationship has problems. Okay, and also why it also fit all the test measurement. Here is the mystery. I'm sorry, I don't know what is the URL. Oh, okay. It says I'm sharing the video. Okay, the mystery of moving mass. In entire modern physics, they're always talking about the mass is no longer conserved. When you move, you have a higher mass. So I was like, where comes this concept of moving mass? Because I'm classic Newtonian mechanics in my life. So I try to find out. And now let's see where comes out this mass.
So the Higgs idea, this whole business, has to do with the origin of mass.
Higgs.
So first, what is
Gauss
mass?
particle.
It's something we're all quite familiar with. You know, when you push on any object, be it a rock, a Mack truck, whatever, the resistance you feel when you push on the object is the mass of the object. Now, where does the mass of the object come from? Well, clearly, it's got to come from the constituents, the particles that make up the object. But then the next question is, where does their mass come from? Especially when we're talking about fundamental particles like electrons and quarks. Where does their heft, where does their mass come from? Here is the idea, according to this Higgs approach. Imagine that space itself is filled with a kind of invisible substance. It's called the Higgs field, but think of it sort of like a cosmic molasses. And then when particles like electrons, say quarks, if they're trying to move through space, they have to kind of push through this cosmic molasses, and they experience a resistance as they try to do so. It's sort of like if you throw a little pebble into a vat of molasses, you can see that the pebble is experiencing a resistance. The same would go for the particles. And that resistance, say when you push on an electron from its interactions with that surrounding Higgs molasses, would be the mass of the electron.
Okay, so now you know why I love this Gauss particle. You know, Peter Higgs, he repeated, universe is filled with these particles, right? Yeah. So so now, basically, this is the best interpretation of where the mass come from to the modern physicists, not to us. Okay. So they said the mass increase is because resistance increase. I said, well, wait a minute. So in Newton's law, we know mass is conserved. Mass is not increased. If resistance